Hello, welcome to the channel. My name is Victor, and I'm going to be your anchor for this training. So this is a 9-part series, or I could still call it a 10-part series for the Data Analytics Essentials training. So we're in Module 5, we're in Chapter 5 of the training, where we're going to be looking at analyze the data using statistics. Understand that data science, data analytics, it's an intersection between statistics, computer, and mathematics. So if you are somebody you don't like numbers, I think this is the time to fall in love with numbers, because it's numbers, most times quantitative analysis we can use to get insight from data. Okay, so let's look at this chapter. So what are we going to be learning? Descriptive statistics, inferential statistics, statistics and big data, visualization. A lot of times a student, a newbie, somebody just starting out is going to be asking, should I do a pie chart? Do I do a bar chart? Do I do a line chart? What should I do? So we're going to be evaluating different types of charts so that you can know as an analyst what type of chart is going to be best for whatever kind of analysis you want to do. So we will normally say once you have the Excel sheet or the CSV file, you write down the KPIs, what you're looking out for, the questions you want to answer. Then the next thing you want to do is to start doing the visualizations. We're going to look at several types of visualizations. Then we want to understand what outliers and anomalies are. So an outlier, take for instance, you are getting data for, let's say, for salaries of entry-level data analysts for a company. And then let's say the maximum salary range is, let's say, $4,000. Now the thing is, what about you get a particular data that is reading $50-something thousand? So that is an outlier. That is way above the average. Or you're trying to look at university students and you see a particular age that is too below, let's say 7 years. If you do the plot, you will see that that is going to be far away from the regular. We're going to see these things, you see them visually. Then anomalies, when you see some kind of things that are not normal with your data, how do you handle it? Then we'll look at VLOOKUP, HLOOKUP. Then we'll see how to summarize this particular module. So to do their jobs effectively, data analysts must have understanding of statistics. So some basis of statistics is very important, right? You need to understand that we are looking at data. Then we want to make some inferences. We want to make some decision based on that data. That's where statistics comes in. And also, we're trying to use statistics to interpret data. We're trying to do some visualizations. And statistics is not something you need to bother yourself about. So basically, you need the foundation, right? And with that, you're able to do quite a lot of work as an analyst. How do you address anomalies in your data set? Then we'll look at HLOOKUP, VLOOKUP, and how to search out for data within your data set. Let's look at descriptive statistics. So basically, you want to describe, right? You want to understand, you want to explore. So after a problem statement, after you've decided a question needs to be answered and the population is determined, some form of statistics analysis is required. And let me talk about sample size. Let me talk about sample size. Sample size. And let me talk about calculate sample size. Let me get a calculator. And let's understand some of the concepts. Now, if your country is, oh, this image looks too small. Let me see this a little bit. have a look for an image that this is still small. This is small, but I'm going to see how to just use it. So if I have a population of a country, let's say it is 10 million, and we are told to do some comparative analysis or to try to find out some compare different let's say style of living, or let us see the effect or the impact of a particular disease on the health of the population, all of that. If it's 10 million, the thing is that you won't be able to collect the data from all of the 10 million persons. It's not going to be possible. So statistics don't work that way. So what you do is that you pick true representation of the entire population and you call that your sample size. Now, when you analyze this data, anything you make out of that data set, you can use that and make some inferences and infer that this is what applies to the entire population. So take, for instance, if your entire population is 200 million in the case of Nigeria, or let's say 250 million, 250, 1, 2, 3. Sorry, 250, 1, 2, 3, 1, 2, 3. So 250. Let's say population of Canada, population of Ghana, population of UK. So for Nigeria, for instance, if I need to conduct a research, and Nigeria, it's my case study, I just need to have 385 persons fill in a questionnaire or a survey, and whatever insight I get from this particular number is a true reflection of this entire 250 million persons. Now, let me give you an example. If you go to Senate, if you go to House of Representatives for most countries, why do you hear the concept? Why do you hear somebody saying, okay, this is my representative, or this is my rep? This is the person representing my constituents. This is the person representing my constituency. This is the person that is representing my town, my village, my city, my area. And anything these legislators or these persons, any decision they make is binding on the 250 million persons. So let's see Nigerian legislators number. I say total number, total numbers, total number. Right? So you have 360. So 109 Senate and 360 House of Rep. So this 360 House of Rep that is actually representing the different constituents, if you check with our calculator, it's no different. That's why any decision they make, it's binding on the entire 250 million persons. Let's see the population of UK, 67 million. So let me go back to my calculator and say 67, 1, 2, 3, 1, 2, 3, 67 million. What's the sample size? Still about 300 and something. Okay, let's see the, I think in the UK, you call them the House of Commons, total numbers, total members in the UK. So you have consisting of 650 persons. Let me see if it's divided. I think it's 2 houses. So you have 308 and maybe another basic of 295 electoral districts. House of Commons has 338, of whom represent a single electoral district called Reading. Now, see this 338 is a true reflection of this 385 you are seeing here. Let's check for let's check for Ghana, population of Ghana. So 32 million. Let me see what 32 million gives us. 32, 1, 2, 3, 1, 2, 3. We have, funny enough, still 385. So let's say Ghana parliament members total number. So I'm trying to use these examples to tell you that in real life, this applies. So you have the seats are 275. So 275 is not too far from 385, just about 100 difference. So we are saying that these guys are a true representation of the entire population. So that's what you call sample size. So because when we're trying to make a decision and inference on the entire population, we can't count the entire population. We just pick out a few numbers, but we must make sure that they are very, very sparsely, they are very, very evenly distributed amongst the number. Like in Nigeria, we'll see from all the geographical locations, from all the states, and all of that. Using statistics. Okay. So there are two key branches of statistics, descriptive and inferential. So descriptives are used to describe or summarize the values and observation of data set. For example, a fitness tracker logged the person's daily steps and heart rate for 10 days. If the person met their fitness goal in 6 out of the 10 days, they were successful 60% of the times over the 10 days period. You could observe that the person's heart rate was a maximum of 140 beats per minute, but an average of 72 beats per minute. These observations could be descriptive statistics that could be used to describe and simplify the data set. So in descriptive analysis, you are taking some observation and you are explaining it in very, very clear terms. Most of the times you're not doing, you're not trying to infer something. You're just trying to do, you're just trying to check what has already happened. You're not trying to make a decision for tomorrow, but you're trying to know what has happened in the past based on the data you've collected. So that's why it's called descriptive. Basic descriptive statistics might include the total number of data points in a data set, things like average, like mean, like mode, like median. And we can use pie charts, bar charts, histogram to be able to depict that. Let's look at inferential. So in inferential, we want to interpret, we want to generalize so that we can do what? Predict something. We can try to tie a relationship between something with respect to that population. So descriptive allows you to summarize findings based on data you already have recorded. However, in situations in which gathering data for a very large population might not be practical or even possible, like I said, it's possible, however, to study a smaller representative sample of a population and use inferential statistics to test hypotheses and draw conclusions about the larger population. So to do this, you now need sample sizes. So let's look at statistics and big data. Now, when you're working with big data, there are some kind of inferential analysis you might want to do. So cluster analysis, you're trying to find groups of observation that are similar in nature. So it's going to be, so you will find this a lot in machine learning. So cluster analysis, or when we do k-means, we do analysis that have to check relationships. If you have a sample size of adults, some are going to be male, some are going to be married, some are going to be married, some are going to be engaged. So right, in cluster analysis, you're trying to look at relationships, how a particular sector, a particular number of observations are related to each other. Then you classify them that way. I remember running a project where you're trying to check visually, even on a map, where a logistics company is to site their pickup point or takeoff point or branches. It's going to be on a map. If you plot this on a map, let me say in a map. Good. So if this is going to be in a map, a moment, let me see something. So awesome. So if this is going to be a map, so as a company, where are you going to site your depot? Where are you going to site your contact point? Where are you going to have, a classical example is Uber. So where are you going to have people? So it's where you have clusters of a lot of requests. So you can use cluster analysis to tell where you have the order, the geographical, the GPS location of all of those orders, and see where you have a concentration. That's why if you drive past some places, you're going to see a lot of Uber drivers like parking there waiting. From analysis, from trends, a lot of people are going to do pick up from that location. This applies to industries, to healthcare. Cluster analysis is going to help you check those kind of relationship between items that are related. Let me use. They're similar to each other. Association, so find co-occurrence of values for different variables. Then regression, quantify the relationship. So here we're going to be saying, is it a positive relationship? Is it a negative relationship? Let me use some pictures to explain to you in detail. So regression analysis. Right, so you're going to see something like this. So these are different types of regression. Oh, no, let me use this. This makes sense. Let me use, okay. This makes sense, but I don't know whether it's going to be a little bit easier for you to understand. Okay, good, awesome. So when you say regression analysis, right? Let me use Canadian population. Right? Let's say which country in Africa had some form of genocide, or any European country that had a genocide? Let's say Israel population. Let's see, Congo Republic population. So now, this is Canadian population. So you see, this is the population size, this is the year. So this is a numeric variable. This is a numeric variable. Also, this is the year 1960 to 2020, right? Then this is the numbers. So if you see, this is a positive relationship. So it then means that as the year is increasing, as we're moving to 2023, 2026, the population is what? Increasing. So we call this a positive relationship, right? So this is a strong relationship. With this, what it means is that we can have 2050, we can be able to tell what the population is going to be in 2050. So we just need to stretch this graph, extrapolate, and we can tell what the population is going to be. So these two variables, don't forget we talked about variables earlier on, these two variables have a positive relationship. So when you see something like this, you plot a graph, you have a positive relationship. Now, let's look at this Israeli population. What happened here between this time? There's an issue. One of the issues is going to be, let's say, genocide. We can start researching Israeli population between 1988 and 1991. So the same thing with Congo, 1990 to 1995, thereabout. You see that there's a steep, right? This is Congo. There's a steep between this point. It's not stretched out like Canada. Canada is very stretched out, no issue, no population issues, no a lot of death rate. But you see in Israel between 1988 to 1993. So let's check that out. Israel population between, don't forget, we said an analyst is a researcher. You have questions, you're trying to look for answers, and it's only data that can help you answer those questions. So Israel between, just a second, Israel between 1988 to 1993. Between 1988 to 1993. So this is your population. If you check population also during the war, you're going to see that, okay, let us check for Congo, if we can see something on Congo between 1990 and 1995. Congo population between 1990 to 1995. Okay, how many people lived in Congo in 1990? How many people were killed in Congo in the 40 years between 1980? Estimated 10 million. Approximately half of the population of Congo died between 1988 to 1920. Let's see what happened in Congo. Okay, let's say what happened in Congo 1990 to 1995. So that is the first Congo War, right? It was named Africa First World War. It was a civil war and international military conflict that took place mostly in. So what happened in the 1990s? So you can see a collapse of People's Republic of Congo, single-party government, and promised multi-party democracy gradually slid into political controversy culminating in the war, right? So between 1990s up to 1999, Congo had war. So that's why you have this, right? 1990 up to this particular moment, right? So that's why you see this steep population. Okay, so enough of that. So just understand that when you have this kind of graph, if you plot it, it then means you have a strong negative population, right? A strong negative population. Of course, when you have you plot your graph and you just see that scattered all over, you cannot do this, you cannot do this, you cannot, you know that there's no relationship between these two variables. So you cannot tell what this variable is going to be based on this particular variable. But if you see this variable, you can actually predict. See this variable, you can predict. So for you to do regression analysis, for you to be able to predict the future from data, if you are going to do regression analysis, it then means you must find relationship. So it might be a positive or a negative relationship. So that means you have to do some graphs first from your data, then you're able to now provide insight. So what are some of the common types of visualization? So we have line graph. So this is what you call a line graph. This is a column, this is a bar. A column is standing, a bar is horizontal. Then you have pie charts, right? So the question is that what kind of chart is going to be best for what kind of data? For pie chart, for instance, okay, let's look at line charts. So line charts are mostly used if you want to do comparison or if you want to do trend analysis. If you want to check like the population, the year that we were checking, you see, the best, you cannot use pie charts to do this. You cannot do, yes, you can use what's it called? Column charts, but line charts will be your best bet if you want to do trend analysis, if you want to check year and some certain numbers, if you want to check what is happening over time, then line chart, it's your best. Let's check trend. Google Trends. So you see in Google Trends, trends.google.com, you see most of the times, if I search in this, I'm in Nigeria, if I search for, let's say, Southtech Ventures, let me search for a company name or any particular item, you can see that particular search term, who is searching for it, if there's enough search term for it. Okay, let me just say Southtech and see if I'm going to see anything. No enough data set. If I see Cisco, do we have any data? Okay, we have some little data. So you see the trend across time. If I want to check for the past 5 years, right? You see the trend. So it's always time. It's always going to be a line. You won't see bar charts here. Let me try. Still wondering why. Still no 5 years, 2004 to present. Let's say data analysis. So highly searched term. You see in early 2004, so the trend is rising up. In what part of the country are people searching more? People are not searching here, I think because of the war. You have more people searching in Oyo, in Niger State, in Kwara, in some, you have a lot of NGOs here, right? Um, so statistic discipline. So these are the related search terms. So you call this, so this trend line is the best, right? Okay, so line chart, if you want to stock prices, number of customers per week, or in the first year or a new retail shop, those kind of charts you want to use a line chart. And of course, for column chart, if you want to check sales in different categories, and if the categories are not more than 5, 10, 15, you can use a column chart. Let's say you want to see sales price or population by, let's say, population by, let's say, different countries, maybe just like 5, 6, 7 countries, then you can use column chart. So some best practices, make sure that you label the axis. These are the axis. This is the x-axis. Sorry, this is the x-axis and this is the y-axis, right? Then fill the column with a solid color. So let's be able to differentiate, like what I was doing on Tableau yesterday in the previous training, I think in series 3. Make sure that it's readable, very, very legible. Let there be space so that we can be able to identify them properly. So bar chart, if you want to check a higher number of items, make sure you label, make sure you fill them with solid colors, make sure there's space in between, right? Pie chart. So you cannot use pie chart if you have items that are more than like 5, 6, 7, 10. Even if you have 10 items, it might be too much for a pie chart. So pie chart is especially when you want to do comparative stuff and you're trying to check stuff over 100, right? So you want to see how each is doing over 100. I think let me do a simple example of these students. Yes, these students. If this was over 100, then I could do what's it called? I could do a pie chart is going to make sense. But if this was if this grand total was, let me make this 0. Sorry. Okay, this is based on a particular data set. Where is data set? Where's data set? Where's data set? I can't find my data set again. Okay, I think this is the data set. So I wanted to, because I can't tamper with this, I have to come to this place and tamper with them. So let's assume this was over 100. Then, okay, let me just create one. Let me create one. Let's assume we have tomatoes, rice, beans, yam, cucumber, if I got that spelling correctly, and we spent $50, we spent $10, we spent $30, we spent 20, how much do you have here? 60, 90, 5 and 5, right? If I have this kind of stuff, I could turn it to a table, Control T, okay, and I can insert a chart. Let me start a chart and choose a pie chart, right? So we didn't give this a name, so let's call this fruits, and let's call this sales expense. Right? So let me delete this. So let me delete this. Let me reduce this. Just a moment. Let me call this my table. Then let me insert a chart and let me use a pie chart, right? Let me use this beautiful one, Okay, good. It's telling me to pay. Let me look for something free, something. Now, are you seeing? So I have a pie chart. See, what's it called? Tomatoes is taking about 50%, right? So I can do a comparison between each of the different items. So I could add the labels, data labels. I could decide which of them to use. Tomatoes, right? Select each of them. So this is what you call a pie chart. So once everything is over 100, if I do a sum, open bracket, highlight everything, close bracket. So you see it's 100. So for this kind of data set, a pie chart is going to make a lot of sense. Not that you can't use other type of chart. You can change the chart and use a bar chart, right? But a pie chart will help you compare how each is doing over the other, right? So that's one of the advantages of using a pie chart, right? So survey results of a group of favorite type of movies. So once you have these, you want to check the different groups and see how they compare to each other. A country's sources, energy sources, you want to check oil, coal, and see how many percent each is granting to each other. Like you see now for my chart, is already telling me how many percent. Let me revert back to the, what's it called? You see, it's already telling me that, oh, tomato is 50%, tomato is 50 and 50%, cucumber is 5 and is 5%, beans is 30 and is 30%, rice is 10 and is 10% of the entire expense that I've made. Okay, so I think we're about rounding up. We're about rounding up. So scatter plot. So scatter plot, very similar to line graph, but you use it if you have so many data points, right? So many data points. Let's say you have up to 20, 30 data points, then scatter plot is going to be your best bet. Okay, if you have anomalies in your data set, how do you handle that? So this is what we call an outlier, right? Something that is out of the regular, out of the normal, where you have other data sets, right? So one thing you can do is that if it's not much, you can take it off, or you can, for that particular point, you can take the average of all of this guy and assign to this particular value. So those are two ways you can take care of outliers. Before data analysis can begin, consider time must be, a considerable amount of time must be spent cleaning the data, right? During data cleaning phase, you may find outliers or anomalies in data. Somebody might be sleeping at this point. Somebody might be exhausted by this time. Somebody might be making a mistake by having this particular item. An outlier is defined as a value or data point that varies significantly from others. So it's quite different from these other ones. Either much smaller or something we have here, you call it an outlier. So in the practical session, if you check our workbook, we have VLOOKUP, we have VLOOKUP, and I think we have also HLOOKUP in our subsequent Excel sheet that we'll be working on. So during the practical session, we're going to work on this. You see the explanation of each of them. Then we'll track as many data sets as possible. Okay, same thing with VLOOKUP, HLOOKUP. In VLOOKUP, we're trying to look for a particular vertical value. Take, for instance, in budget, you're trying to look for the budget of, let's say, a movie 71. So it's going to take 3 parameters. It's going to take the particular item you're looking for, then it's going to take the item you're looking for, that is the budget. Then it's going to take which of the movie title, for instance. There's going to be, these 3 has to do with where are you looking at. So you count 1, 2, 3. So you're going to pick this, then by the default is false. Once you enter it, this will bring out the budget for the movie title. So whichever movie title that you select is going to bring it out. So we'll do these things hands-on. Okay, so that's for some analysis that you can run on Excel. So this gives you some kind of basics on the kind of thing you can be doing to your analysis, to your data to either prepare it. You've understood what sample sizes are, how to calculate sample sizes. And for the sample size, for instance, there's a sample size have their formulas, right? Sample size have their formulas. So maybe we'll consider that later on. Okay, I think that's all for this particular session. How to address anomalies, VLOOKUPs, looking at something. Also HLOOKUP, we'll look at that in the hands-on session. Okay, I think that's all for this series. Thank you very much. If you have questions, you can put a comment in the YouTube session, or you can ask in your training group and we'll do justice to that. Thank you very much.